Hello, my name is David Black, and this is an explanatory video for my Constellation in a Box lesson plan. This lesson was developed for my 6th grade integrated science class several years ago. One of their learning standards is to understand stars and constellations. I had previously published a lesson plan in The Science Teacher, the magazine of the National Science Teaching Association, which asks students to build an accurate 3D model of the nearby stars out to about 15 light years. Since it involves using trigonometry to find the angles and distances for the stars, it is at too high of a level for most 6th graders. Instead, I developed this lesson, which still involves learning about the scales and proportions of the stars, but uses simpler math and more familiar concepts. This activity is good for grades 6 through 10. Prior to this lesson, students need to have a basic understanding of the differences between stars and planets, and between constellations and asterisms. It meets a number of physical and earth science standards from the next generation science standards, including Earth's place in the universe, the patterns and apparent motions of the sun and stars, the science and engineering practices of developing and using models, analyzing and interpreting data, and the cross-cutting concepts of time, space, energy, scale, proportion, and quantity. For the Common Core math standards, this lesson involves ratios and proportions and constructing models using math. I have listed the specific standards that apply in the lesson plan itself, as well as a list of required materials. By the end of this lesson, students will be able to identify the mythologies of their chosen constellation, as well as the names of its major stars, along with their spectral types, relative sizes, and coordinates. They will build an accurate scale model of the nearest stars in that constellation and determine how the constellation appears to shift due to parallax, or a change in the observer's position, as well as how the stars themselves move over time. Another objective is to teach students how to use Stellarium, a free browser-based planetarium software package for laptop computers and cell phones. In the lesson plan, I have described each day's activity. It should take about 4 to 5 days to complete. For the first day, students learn how to use Stellarium to find their zodiac constellations. Students will list the constellations and star names they are familiar with, and the teacher will add interesting facts and vocabulary as the discussion progresses. This is meant to be a hook, to start with what students are familiar with, what they already know, and then extend it to new knowledge. For example, a student is likely to say that the Big Dipper is a constellation, when in fact it is actually an asterism, or a pattern of stars. The teacher can mention that there are 88 constellations covering the entire sky, and that several of the characters in the Harry Potter books by J.K. Rowling are named after stars, such as Bellatrix Lestrange, Sirius Black, and his brother Regulus Arcturus Black. They will enjoy knowing that Bellatrix means warrior woman in Greek, and that Sirius is the dog star. Very appropriate names. Once this beginning discussion is over, the teacher will introduce Stellarium and show students how to use it, and then the students will learn how to search for stars, how to turn on and off the constellation and asterism lines and star magnitudes, and work with constellation images based on the Bayer's Uranometria. They will also learn how to find mythologies about various constellations from multiple cultures. They will end the first day by choosing their group's constellation. In subsequent days, students use Stellarium to write up a description of the mythology of their constellation and develop a list of the brightest stars in that constellation along with their spectral classes, sizes, and coordinates, and create the backdrop star map for their models with a regular grid of lines about 2 centimeters square. An easy way to create these maps is to use Stellarium to project the constellation onto sheets of paper so that students can simply trace the constellation and asterism lines. The students will then color in and label the stars on the map, then tape or glue the map on the bottom of their banker box. Using the instructions with the diagrams shown in the lesson plan, students will determine the scale of their model by finding the distances to the stars in light years and the depth of the box, then calculating a proportion for how many light years equals 1 centimeter. They will hang up their eyepiece, which is a canning jar lid, at the open end or front center of their box. Using a sharp compass point, they will poke holes in the top of the box in the correct proportion of distance that they calculated and in line with the star on their map, using the eyepiece to sight in on the star's position. The stars will be made from wooden beads that are painted to represent the spectral types, and with different sizes to represent if the star is a giant or a subgiant or a dwarf star. Each star bead will be hung on a thread, then lowered down from the hole in the top of the box until it lines up with the star on the map, and the string will be then taped. When all the major stars are hung, the students should be able to look through the center of the eyepiece with one eye, with their face against the ring, and their other eye closed, and see the stars lining up with the map as shown here. They may need several tries to get it right. The position of their eye against the ring represents the position of our solar system. On the final days, the students will look at the stars from different positions by moving their sighting eye a specified amount to the left or right, then charting the positions of the stars as seen against the background grid. The closest stars should appear to move more than the further stars. In reality, the stars are not moving, but the observer is moving. This effect is called parallax. If we were to travel even a few light years away from Earth, all of the constellations would appear distorted for this reason. Once the students have charted the stars' parallax positions, they can answer the questions at the end of the lesson. To assess the students' work, the teacher can look at the quality and accuracy of their model, how well they have charted the parallax positions of the stars, and the thoroughness and correctness of their answers to the questions. For differentiation purposes, students can be provided with all of the measurements for their stars in advance, instead of calculating the proportions themselves if needed, or they can chart the parallax positions of a pre-created constellation box. For global awareness, students can learn multiple names for the stars, not just the Greco-Roman or Arabic names that we are used to. They can design a constellation using the mythologies of Chinese, Native American, and Polynesian cultures. This lesson plan is an example of project-based learning, where students learn through building, making, creating, instead of passively sitting and listening or reading. Because they will find building these constellations to be fun and meaningful, they will look up the information they need and teach themselves, as long as the teacher allows them the room to be creative and provides the scaffolding and the hook to help them be successful. Project-based learning in science classrooms to enhance student engagement, creativity, and content learning will be the subject of my upcoming dissertation research. Thank you.